I'm Miss Morocco.
Hi, I'm Julia and I studied vaccine type.
I'm Azalea.
And I'm Ronnie.
And we both studied blood type.
I'm Casey.
And I'm Abir.
And we studied underlying conditions.
Hi, I'm Sarah and I studied age.
Hi, I'm Jasmine and I studied gender.
I'm Anaga.
And I'm Claire. And we studied previous infection.
Hi, I'm Kyle Johnson. I'm the VaxFacts data analyst and tech support.
Introduction. This graph is taken from the Dutchess County COVID-19 Community Impact Dashboard website. This graph shows the total number of deaths from COVID-19 as the months go on. As you can see, the graph spikes and then levels out periodically. This happens because cyclical spikes of COVID-19 cause cyclical bursts in the total number of deaths. Project Origins. First, the global pandemic hit in 2020. New vaccines were introduced as a potential solution. Once people started getting vaccinated, it was leaving peers and teachers in bed with a variety of side effects. Miss Morocco wondered why one person might experience different side effects than another. The project was a good choice when most students were under remote instruction. Thus, the Vax Pack was born. Now, this is our project timeline. In February 2021, our first survey was sent out. In March, we edited and revised our first survey, fixing the errors in our questions. In April 2021, the second survey was sent out. And then in May 2021, we purchased Tuva Labs, a program online that helps us better interpret data and create graphs. And then in June, we compiled data from the first survey and stopped receiving responses. In September, we combined the data from both surveys so we can better analyze it. And then in October, our background research began, and we compared our background research to the conclusions and trends we saw in our data. In November, we created graphs from the completed datasets using Tuva Labs. Then in December, we started our slideshow. In January, we edited our slideshow. February, we finalized our slideshow, and now we are recording it to show it to you guys.
Hi, hello everyone. I'll be discussing the goals that we had for this project. So the first thing obviously was to collect data. So the first step in that process was to distribute the form that we had made with questions we wanted people to answer. So that included emailing teachers and administrators to share the form with their students and community members. We also posted flyers with a QR code to have it filled out around the Arlington High School. Next, we developed a second form. So our first form included qualitative questions, things like, did you experience symptoms after the first dose? If so, what were they? Like fever, myalgia, things like that. And we really wanted quantitative data because that more accurately can be used to present it. So we edited the original form to gather quantitative data. So for example, if we asked, did you experience myalgia? It would be followed up with, if you did, then on a scale of 1 to 3, like how painful was it? The final thing with that process was to combine the data from the two different spreadsheets developed by Google Forms into one spreadsheet to upload into Tuva Labs, which was the software that we used to next analyze the data. So that included first exploring the data and then splitting up into groups to tackle different variables, for example, blood type, gender, vaccine type, things like that. And finally, trying out different graphs to decide what most accurately represented the data. So we used pie charts and line graphs and bar graphs and a bunch of other things that you will see as the presentation goes on. So I'll pass it over to the next person.
Hi, my name is Julia Pomeroy, and today I will be discussing the different types of vaccines our survey respondents received and what effects those had on their post-vaccine symptom severity. The three vaccines that the people who responded to our survey received were the Pfizer, Moderna, and Johnson & Johnson vaccines. So both the Pfizer and Moderna vaccines are mRNA vaccines, meaning that they do not have any piece of a live virus in them. They instead work by teaching ourselves how to make a harmless piece of spike protein, which is found on the surface of a virus that causes COVID-19. After making the protein piece, the cell displays it on the surface of its cell, and our immune system then recognizes that it does not belong there and responds to get rid of it. When an immune response begins, antibodies are produced, creating the same response that happens in a natural infection. So the Pfizer vaccine is 95% effective for people ages 16 and older. And the Moderna vaccine is 94.1% effective for ages 18 and older. To be considered fully vaccinated, you have to receive 2 doses of the Pfizer vaccine and 2 doses of Moderna vaccine, which are roughly 3 weeks to a month apart. And then the CDC recommends a booster dose 6 months after the second dose for both of these vaccines. Now, the Johnson & Johnson vaccine is a viral vector vaccine. which uses a modified version of the virus that is different from the virus being targeted to deliver important instructions to ourselves. The modified version of the virus itself is called the vector virus. You only need one dose to be considered fully vaccinated. However, a booster dose of either Pfizer or Moderna is recommended after the second dose, as it is significantly less effective than the previous two vaccines. There is a rare risk of blood clotting to women under the age of 50. The AstraZeneca vaccine, which was not approved in the US, just due to the fact that we didn't need it, was the AstraZeneca vaccine, which used the viral vector method. So out of the 532 responses we received, 9.6, or roughly 10%, received the Johnson & Johnson vaccine, roughly half received the Pfizer vaccine, and 40% received the Moderna vaccine. We believe the higher percentage of Pfizer vaccine was due largely in part to which age group the vaccine was approved for. So for example, our responses were largely from our school community. So our teachers, which received the vaccine first, and then our student population. Moderna was not approved for kids under the age of 18 at the time. So every high school kid in our school received the Pfizer vaccine, which is why the percentage is so high. So the first symptom that I'm going to examine is the reported instances of fever from the 12 to 24-hour mark. Now, all of the data points I'm going to show you are from the first dose of vaccine because the Johnson & Johnson had only received one vaccine at this time, so it would have been difficult to compare all three. So if you see on the right over here, this is your key to what you're looking at. So the lighter colored blue means no fever was reported. So if you look to the right here, where it says dose 1, 12 to 24-hour fever, this is the key, is how you can read the chart. So we labeled our symptoms from 0 to 3, 0 meaning you did not have a fever, and 3 meaning you had a high fever or a severe symptom. The vast majority of people did not have a fever at this point. However, you can see that it was more prevalent in people who received the Johnson & Johnson vaccine, and the Pfizer and Moderna vaccines reported very similar numbers. So 93 and 92% of Moderna and Pfizer recipients reported no fever, while 73% did. So a little more than a quarter of people with Johnson & Johnson had a fever at this point. All three vaccines reported very low findings of severe fever, but 16% of people who received the Johnson & Johnson vaccine did report a low-grade fever. The following graphs are showing how many of our survey respondents reported having a headache right after vaccination up until the 12-hour mark. 72% of people who received the Pfizer vaccine reported having no headache. 77% of people who received the Moderna vaccine reported having no headache. And 65% of Johnson & Johnson recipients reported having no headache. Roughly 16% of people with Johnson & Johnson vaccine reported having a low-grade headache. And 16% of people who received the Moderna vaccine reported having a slight headache, as opposed to 14.5 people who had the Pfizer. I included this graph, even though it doesn't show significant findings, to illustrate how not every symptom was affected. So this graph is showing how many people were experiencing nausea 24 to 48 hours after their first dose. So this is an example of a symptom that we do not think was really impacted by vaccination, as 98% of Johnson & Johnson recipients, 97% of Moderna, and 98% of Pfizer recipients reported no nausea at all. What can we conclude from this? The mRNA vaccines showed the most similarities in symptom severity, but not all symptoms were affected. This makes sense, as Moderna and Pfizer are constructed using the same basic technology. However, I would like to say that some of these discrepancies can be accounted for variations in sample size and what constituted those sample sizes. For example, our Johnson & Johnson population was significantly smaller than that of our Pfizer population. Also, as a whole, the people who received Pfizer were generally younger than those who received Johnson & Johnson or Moderna. So all of these could have had an impact on one another. The farther and farther people got out from their doses, both first and second, the less they reported having symptoms and the less severe they were. As a whole, the majority of people had little to no symptoms, making these vaccines very safe and relatively low impact on people's health and lives. These symptoms did not last for very long, nor were very severe. Thank you for your time, and I'm going to hand you off so you can learn more.
The effects of blood type on COVID-19. Studies from the American Society of Hematology have shown that people with type O blood and people who are Rh negative have the least severe COVID-19 symptoms. People with type B blood have less severe COVID-19 symptoms, and people with type A, type AB, or people who are Rh positive generally have more severe symptoms. While research is still being conducted on this topic, researchers assume this trend has to do something with the antigens associated with different blood types. Does this background research match our survey? These graphs show Rh factor and how it affects myalgia on the first dose during the initial 12 hours after the vaccine was received. Myalgia means muscle fatigue. On the right of the screen is a key. The lightest color means that the participant did not experience any myalgia. The second lightest blue indicates that the participant experienced some myalgia. The second darkest blue indicates that the participant experienced moderate myalgia, and the darkest blue means that the participant experienced extreme myalgia. The pie graph on the right shows people who are Rh positive, and the one on the left shows people who are Rh negative. As you can see, the difference in the percentages between the two graphs are minimal. Unless we conduct more surveys with new people, we can't draw any valid conclusions when the difference between the graphs is so minute. The same can be said about myalgia 12 to 24 hours after the first dose, as well as myalgia 24 to 48 hours after the first dose. As I analyzed data for the second dose, I noticed the same trend. The percentage makeups of the pie graphs were very similar, and it was difficult to draw any conclusions. It seems that Rh factor did not affect myalgia at any time after the first or second dose for the participants in our survey. Moving on to blood type, at first glance it seems like blood type plays a role in the severity of COVID-19 symptoms. Type O blood experienced the least amount of fatigue, 12 hours after the first dose. This agrees with our background research. However, people with type AB blood also experienced minimal fatigue. This may be because less than 5 participants in our survey has type AB blood, seriously skewing our results. As we look at other graphs, there doesn't seem to be a trend. Because so few participants in our survey identified with less common blood types, it is difficult to draw valid conclusions from the data we collected.
Hello, my name is Ronnie Geiger, and I'll be taking you through how blood type affects COVID vaccine symptoms. The first graph I'd like to show you is a injection site soreness after the first dose. And as you see here, it's pretty spread out, very evenly distributed between all the blood types. We definitely saw, and this is a common thing, the O positives and O negatives definitely had maybe like slightly more severe symptoms than the other blood types, the other participants' blood types who were more A plus, A negative, B plus. But as you can see here, there really isn't a clearly defined trend of just of soreness regarding blood type after the injection site, after the first dose. Here is another thing. This is after the second dose, a headache, 12 to 24 hours, a very common symptom for many after their second dose of Moderna or Pfizer. Similar to the past graph, we found not a clearly defined trend. You could again argue a little bit that O positive and O negative again might have a little more people who have severe symptoms than the others, but again, nothing that out of the blue, not very evenly distributed, nothing that would make us think that there's a clear trend regarding blood type and headache intensity 12 to 24 hours after the second dose. Again, one of the very common symptoms is fatigue that we saw after the second dose. Here is another chart. As you can see here again, O plus, O negative, mainly O plus actually in this symptom. 1 to 2 days out after the second dose, we definitely saw maybe more O plus might have had a more severe symptoms. But again, across the blood types, the participants with AB, A negative, B negative, they're had similar experiences. There was very evenly distributed between the blood types. We can conclude from this that blood type does not play a significant role in the vaccine symptoms, we cannot clearly define trends. The role of the blood type is not inclusive enough.
Hello, my name is Abir, and for this part of the presentation, I have worked on the effects of underlying conditions on COVID-19 and vaccine side effects. After doing some research, cdc.gov on the effects of underlying conditions on COVID-19 vaccine side effects, we came to the conclusion that certain underlying conditions put you at a higher risk for severe illness from COVID-19. These medical conditions, which heighten your risk, we split into two groups. The conditions that cause you to be immunocompromised, which means that immune system defenses are low, affecting the ability to fight off the infection and disease, and which lead to less side effects, but a heightened risk. And also for conditions that weaken COVID target cells, including lung cells, nasal passages, and intestine cells. So for the conditions that cause you to be immunocompromised, these include cancer treatment, bone marrow, or any organ transplant usually, and immune deficiencies. The conditions that weaken COVID target cells would be asthma, cystic fibrosis, lung cancer, or any kind of cancer. For the underlying condition that I looked into, I did underlying conditions in myalgia. The effect of having underlying conditions on the severity of the myalgia symptom. So myalgia is pain in muscle or muscle groups. And I looked into the severity of myalgia in those with underlying conditions and without underlying conditions for dose 1, 12 to 24 hours, and dose 2, 12 to 24 hours. Before I go into anything, I would like to point out that those with underlying conditions are on the right, and those without underlying conditions are on the left. On the side here, we have the gradient. So this shows the severity of the myalgia symptom. So the darker the blue, the more severe the myalgia symptom a person is experiencing. And the lighter it is, the less severe the myalgia symptom is. So for dose 1, we could see that these pie charts are fairly proportional, so no conclusions can be drawn from these graphs, but what can be pointed out here would be that in the dose 1, those with underlying conditions experienced heightened severity of the myalgia symptom, and those without underlying conditions, less of them experienced the highest severity. As you can see, it's 23% for those without underlying conditions, and 29% those with underlying conditions. For the second dose, there's a dramatic increase in the people who did not experience or experienced very little myalgia symptom. As you can see, this is a very light blue, and from the previous dose, it was 32%, about a third of them experienced little to no myalgia symptoms. But here it doubled. So about 60% in both experienced little to no myalgia symptom due to this blue color, very, very transparent blue color here. But what can be pointed out here is, like the previous slide, those with underlying conditions experienced a heightened severity than those without underlying conditions. But the difference here would be that those with underlying conditions, 5% more than those without underlying conditions experienced little to no myalgia symptom. This can be attributed to the fact that those with underlying conditions have a weakened immune system. The weakened immune system causes a heightened risk of COVID-19, but the symptoms are not as severe because the immune system is not at its peak. It does not work as well as those with underlying conditions. So an immune response equals the side effects. If there are no symptoms, that means that they have an immunodeficiency. So as can be seen here, it can be stated that although it's not a very big difference, 5% of those with underlying conditions experienced little to no myalgia. That will be all. Thank you for your time.
Okay, so moving on to the next part of our slideshow, I'm going to be talking about how whether or not one had an underlying condition affected the COVID vaccine side effects, specifically fever. I was originally going to study how allergies, whether they be food allergies or seasonal allergies, affected the COVID vaccine side effects, but I had a lot of difficulty trying to separate the data for that. So I decided to generalize the topic and study how underlying conditions affected fever instead. So what I did was I split the participants from our survey into whether or not they had an underlying condition. And I decided to compare the two pie charts. So as you can see from the color gradient on the side next to the graph, the darker the blue, the more severe the fever was for those people. And as you can see on my first graph, which is the first dose, the initial 12 hours, in each group of people, there was a small percentage of people who had fever, not a huge percentage, but there still was a percentage. And in the underlying conditions relative to the size of the group, there was a higher percentage of people who had fever or a higher severity of fever than there were for people who did not have an underlying condition. Moving on to my next graph, it is comparing the first dose, and it is 12 to 24 hours. As you can see, there is still a percentage in each of the groups that had fever, but you can see they're equaling out, you could say, during this 12 to 24 hour period. And moving on to the last graph for the first dose, this is the 24 to 48 hours. And as you can see in both groups, the numbers are starting to dwindle down. They're getting less and less. Moving on to my next graph, this is the second dose. And it's actually a problem with our survey. We did not seem to find the data for the initial 12 hours of the second dose. So I'm going to start off with the 12 to 24 hours. And as you can see, compared to the first dose, people who had the second dose had a much, much greater percentage of people who showed fever and a higher severity of fever. As you can see, relative to the size of these groups, a higher percentage of people with an underlying condition had fever than if they did not have an underlying condition. It's the second dose, and it's 24 to 48 hours. As you can see, the numbers start to decrease a little bit, but you can see a pattern throughout a lot of the graphs that a higher percentage of people relative to the population in each group, people in the underlying condition, there's a higher percentage that had fever than the percentage of people who had fever if they didn't have an underlying condition. For conclusions, underlying conditions did play a role in the severity of a person's side effects to the vaccine. Those who have an underlying condition tended to experience more fever or higher severity of fever than those who did not have an underlying condition.
Hi, I'm Sarah, and today I'm going to be talking about the effects of age on the COVID-19 vaccine side effects. So starting off, I'm going to be discussing the two things we used to kind of find our research. So we had like a background research, and in general, according to our background research, which was the CDC, age does affect side effects after receiving the COVID-19 vaccine. Younger people tend to develop symptoms more quickly, and they are generally more intense. And in our personal research from our survey, we found that people who are in the 16 to 24 age group are more likely to experience myalgia after their first dose, but not really after their second. And just to explain really quickly, myalgia is general body soreness. Before I get into explaining my graphs and the data that I found, I'm going to explain them really quick. So here is dose 1, and you can see that this is in the 12 hours, and then of course it's labeled myalgia, and then we have everything color coordinated and color coded to go along with the graphs. So as you can see, our 16 to 24 age group has the highest percentage here, which meant they experienced the most myalgia out of everyone in the survey. And this is really surprising because our 16 to 24 age group had the least amount of respondents to it. And the group that had the largest number was 41 to 50. So generally you'd expect that group to have a higher response to myalgia, but they didn't. Going on to my next slide, you can see that this is still dose 1, and this is the 12 to 24 hours after receiving the vaccine. And you can see once again that 16 to 24 has the highest percentage out of the entire group. And you can just see that the 41 to 50 has 23 compared to 28%. Once again, we're still on dose 1 in the 24 to 28 hour bracket after receiving the vaccine. And once again, you can still see the 16 to 24 age group has the highest response to myalgia. Now moving on to dose 2, as you can see in the 12 to 24 hour age bracket, you can see that this number drops significantly down to 21% compared to the 41 to 50 age group, which has 25%. So you can see that this is dropping down. While we don't have a conclusive answer for why it's different in dose 1 and dose 2, or why even in general the 16 and 24 age bracket has that high number of response, it's believed it could be to immune response, but once again, with all this vaccine data, it's very new, lots of research is being done. Once again, still in dose 2, 24 to 48 hours, you can see that the number has dropped down to 19% in the 16 to 24 age group, and in the 41 to 50, it is 25%. And that's it.
Hi, so I'll be going over the next variable, which is on effects of gender on COVID-19 vaccine side effects. So I first wanted to look at some background research relating to this subject, and to preface that discussion, I wanted to mention that all of this research has been published by the National Institute of Health. So the first thing is that the TLR7 gene is located on the X chromosome, and it detects viruses and initiates immune responses. And it's been found to be stronger in women, which is actually really important because it could explain why women are experiencing a greater severity in vaccine symptoms because they have a greater immune response. The next thing is that the ACE2 receptor, which allows SARS to enter and therefore allows COVID to enter, has been found to be in a higher concentration in the blood of men, which could imply that men are more susceptible to COVID-19 than women. To back up that statement, it has also been found that in other animals, male hormones have a higher affinity for ACE2 as well. Some more background research, the estrogen hormones and ESR1/2 receptors put together inhibit SARS-CoV-2 cause inflammation and immune response signaling in host cells, as found by one journal article. At the same time, however, estrogen loss to an extremely low level in females after about 55 years of age causes the increased fatality rate of women. So if you're confused at this point, you are not alone. I definitely was when I first read it too. We just read two different conclusions relating to gender and immune responses. In one that they diminish immune responses, and in the other that they heighten immune responses. So essentially the conclusion drawn by a lot of these journal articles and by myself when I look at them is that there currently is a lack of gender-oriented research, and because of that, we can't really form many strong conclusions. So with that in mind, we can go on to our research from Arlington. So the first thing I looked at was gender versus first dose 12 to 24-hour fatigue. And to reiterate what other people have said, the darker colors indicate greater severity in symptoms, as you can see here, 3 or greater. So in this one, you can see that in females, there is a 6.2% of women facing symptoms of fatigue 3 or greater, and in males, it is 5.9%. So there it is pretty much the same. In this next one, we're looking at the same thing as before in terms of first dose, 12 to 24 hours, and fatigue. However, we are now filtering out every age except for 41 to 50 so that we can keep age constant and really look at gender and symptom severity. Also because 41 to 50 is one of our bigger population sizes for age. So in this one, we're actually going to look at the less severe symptoms because there simply is just too little to look at the greater severity. But in the less severe symptoms, meaning people who experienced less symptoms, 58% of women versus almost 64% of men. So that's kind of a bigger difference that a lot of women, there are more women who experience less severe symptoms. Going on to the filtered age of 51 to 60 to see if it's consistent, we can actually see that there is a more stark contrast for the same conclusion though. So for females, almost 55% experienced less symptoms versus almost 87% of males experienced less severe symptoms. So the same conclusion, but definitely more stark than what we saw just before. However, then we look at a different symptom, 12 to 24-hour headache with the same filtration as the first one, age 41 to 50. And we actually see that 72% of women experience less severe symptoms and 76% of males. So here we can see that inconsistent because there is a more equal experience, about 72%, 76% of less severe symptoms, which doesn't match with what we just saw before. That was 55 to 86%. So from all of this background research, we can see that we are consistent with background research that says a lack of gender-oriented research causes inconclusive results. Because, for example, in 41 to 50 age range, 3 times more women experience severe fatigue versus in the 51 to 60 age range.
So
3
next we
times
want
more
to
women
look at the
experience fatigue.
effects of previous infection on COVID-19 vaccine side effects. So before we did our research, we wanted to look at what other researchers had found when they researched the effect of previous infection on this vaccine side effects. According to a study done by Zoe COVID Study, which is a study done in the UK in 2020, 33% of those previously diagnosed with COVID-19 has systemic side effects to the vaccine. And 19% of those never diagnosed with COVID-19 had systemic side effects to the vaccine. So systemic side effects means that they had whole body side effects. And so based on this previous research, we had an idea going in that if you had COVID-19, you were more likely to have worse side effects to the vaccine. So then based on our research and our data, we found that generally the second exposures to the COVID-19 virus yield more severe side effects. So what do we mean by second exposure? So for those who previously had COVID, their first dose of their vaccine is considered their second exposure, because their first exposure would have been when they had COVID. And for those who never were infected with COVID-19, their first exposure to the virus is their first dose, and their second exposure is their second. And now we are going to look at some graphs to prove our point.
Looking at dose 1 of 12 to 24 fever, if we're looking on the right side over here, there's a small chart with a lighter blue correlating to a mild reaction, and a dark blue is going to correlate to a more severe reaction. So if you look at our graphs here, the group on the left is the first exposure group because they previously have not had COVID, so this is their first exposure. And the group on the right has had COVID before, so this is their second exposure. And as you can see, the group on the left here definitely has a more mild to moderate reaction to fever, whereas the group on the right, the second exposure group, has a more severe reaction. And that can be shown through the bigger percentage of severe/moderate symptoms. And if we look at dose 2 of the 12 to 24 fever, now the group on the left here is experiencing their second exposure, considering they had not previously had COVID, whereas the group on the right is now experiencing their third exposure, considering they did have COVID. And as you can see, the group on the left here definitely has a more severe to moderate reaction than they did in the first dose, and the group on the right, who's now experiencing their third exposure, has a more moderate reaction. This trend can also be supported in different symptoms. So we're looking at 12 to 24-hour headache here, and this is dose 1. So the group on the left, again, is their first exposure, and they've got a mild, slightly severe reaction, whereas the group on the right is experiencing their second exposure, considering they have had COVID before, and they have definitely a more severe reaction. And now looking at dose 2, we can see the group on the left, who's now experiencing their second exposure, has a more severe reaction than they did in dose 1, and the group on the right, who's now experiencing their third exposure, also has a severe to moderate reaction. So as we can see through the data here, second exposures tend to lead to a more severe reaction.
Sources of error. Throughout our research, we identified possible sources of error. Halfway through our presentation, we encountered the need to create a new and improved survey, causing a more complex situation for users. We also had a limited sample population. Our data is concentrated on the 41 to 65 age group and only represents people residing in New York. Additionally, we encountered an error when transmitting data to Google Sheets, causing missing values and extra work to retrieve data points lost to Sheets. If we could redo this research, here's some variables we would have changed. We would have factored in menstruation, weight, environment, or location, which arm our participants received the shot in, and whether it was their dominant arm or not, whether participants were taking hormonal supplements such as birth control at the time of their vaccination, and how long ago our participants had COVID-19. If we consider these variables, our data and conclusions might have well been changed. And here is our works cited slide. Thank you so much for listening to and watching our presentation.